Greetings. Before we start, this is the snapshot of the meetings that we have conducted for 2 times. The first meeting was conducted on 14th of July using Zoom, and the second meeting was conducted on 16th of July using Zoom as well. These are the group members for Group 5, which are Nurhanis Adini, Nurul Ashikin, Aina Nadira, Maitasha Alia, and Nur Shasha Adriana. We will review on the article published by Okori and Obwa in 2011, which is on machine learning classification technique for famine prediction. Before we start, let us watch the animation video that is prepared by all of us.
Hi everybody. Famine has put the society at risk in several regions. According to the World Food Programme, there are millions of people living with hunger, and the number has risen as coronavirus spreads across the world. So, the scientists are trying to investigate ways to reduce the disturbing famine, and these are the scientists, which are Dr. Hanis, Dr. Tasha, Dr. Shikin, and Dr. Shasha. Soon, they started to search for the related articles as a reference to investigate famine. Fortunately, Dr. Tasha found an interesting article about machine learning in predicting famine. Then, the leader asked each of them to extract the important information from the article. Now, let's hear from them how machine learning can enhance the classification accuracy in predicting the risks like famine.
These are the contents for our presentation. Now, let's begin the review with Dr. Shasha for the introduction part.
Okay, thank you, Aina. So for the introduction, famine can be defined as the state of hunger or insufficient food supply which resulted in death and unchanging economic landscape. It is caused by multiple aspects which include poverty, war, and drought. As stated in the article, early famine prediction can actually avoid or control this problem. Therefore, a study was carried out to precisely predict the famine-prone household by applying the 4 machine learning techniques, which are support vector machine, SVM, k-nearest neighbor, KNN, naive Bayes, NB, and decision tree, DT. Machine learning is an application of artificial intelligence where the computer system have the ability to learn automatically without being explicitly programmed. Previously, parametric techniques and non-parametric techniques have been applied in similar studies. As what the researchers conveyed in their article, non-parametric techniques like classification and regression cards showed probability levels of prediction. Hence, they have an advantage over parametric techniques. In the learning aspect, the researcher in this study applied the supervised learning to enhance accuracy of the famine prediction classification by splitting the data into training and validation. Furthermore, SVM and KNN have been proved to be suitable for identification and classification of famine-prone households because of their stability and better generalization. Between this method, the generalization performance of SVM, SBM is better since it depends on the support vectors that give way to maximal distinguishment between classes, thus reduce the chance of misclassification. The purpose of their study is to utilize ML techniques in accurate classification of households inclined to famine. This is achieved through dataset threading for prediction of food insecurity, presenting different levels of accuracy using different measurements, as well as evaluating this prediction accuracy using area under the curve AUC. So for the next part is materials and methods.
For materials and methods, the data used in the study were obtained between 2004 to 2005 from agricultural households in different parts of Uganda, where the population is 31,135,292. In Uganda, agriculture crop production is their main economic activity. For example, sesame, sweet and Irish potatoes, banana, beans, and many more. The data collected showed that there were 5,040 cases, but only 3,040 cases were left after removing the missing cases. In the survey, 24 features used to produce food products and crop quantities were discovered. However, 9 features out of 24 features were not included as they were converted into other variables to reduce classification noise and data variability, and also speed up the operation of data mining algorithms. For each household, dietary energy intake was also calculated depending on their food balance sheet. However, after transformation similar to the above features, only 15 variables were used to classify the household food security status. Next is household classification and performance evaluation. Classification of households from 4 different parts of Uganda were done using SPM, KNN, NB, and DT in order to prove regional involvement. The accuracy, area under the curve, specificity, sensitivity, error rate, and receiving operating characteristics or ROC were used to evaluate the performance of the 4 machine learning techniques used. Next is visualization of classification. The training and testing data on dietary energy intake and household size were presented by visualizing the classification. Also, Z-score was used to normalize the values. Visualization tells the reader on how the training and testing data can be separated into feature space with known and predicted classes to form attractive patterns. That's all for materials and methods. Now I'll pass the presentation to Dr. Shikin for the results part.
Okay, thank you, Aina. So next I will present on the results. So Okori and Obua in the article presented the results on 2 main components, which are prediction evaluation and also visualization of classification. So next. So in the first component, which is prediction evaluation, they evaluated and measured the prediction value of 4 different methods by the 4 main aspects. So based on the data collected in figure 1, they compare the 4 main aspects of machine learning methods, which are specificity, sensitivity, accuracy, and also area under the curve AUC, and it showed that the northern region experienced more famine compared to other regions in the country. Besides, the figure also proposed that the data from the northern region outperformed the data from the other regions. Next. So the figure shows comparison of prediction performance of 4 different methods. From the figure, KNN is shown to have the highest sensitivity average at 80% compared to other methods. Moreover, all 4 approaches had comparable average error rates that are less than 35%, which is good as it falls below 50%. From there, it is comprehensible that KNN had the highest average sensitivity of 80.63%, while SVM, NB, and DT had between 65 and 70%. Next. So as you can see from previous figures, the data provided from the northern region is reported to perform better than data from the other regions. Hence, it was used to train data from other regions using different methods of classification such as SVM. So the results of the prediction are as shown in the table. Support vector machine SVM and KNN showed substantial sensitivity improvement in Western region that had performed poorly before using North data for training. Next. As you can see from the table, support vector machine showed less specificity reduction compared to KNN and provide best results of over 90% for the area under ROC curve for all other areas, thus supporting its generalization ability, which is suitable for prediction in a study like famine. Next. So the next component is visualization of classification. In the second component, they evaluate visualization classification, where results from the feature space are shown on 2 dimensions of dietary energy consumption and household size. The visualization showed how to split the training and testing data sets into feature spaces with corresponding known and expected groups in order to create interesting trends. Compatibility of machine learning in famine prediction is also indicated by the trained dataset fitted within the training dataset. That's all for results. Next, I will pass to Dr. Hanis to continue with discussion.
So thank you, Dr. Shikin. I'll continue with the discussion. So based on the results that they have obtained, it shows that the data from the northern region has more consistent and reliable results compared to other regions. Hence, this result can be applied to other regions that had a poor famine prediction performance. For the eastern region, the performance prediction ranked close to the northern region as it indicates the similarity in the data set. This reveals that the northern region is more prone to food insecurity that they have been experiencing for almost 20 years. They are more prone to food insecurity due to adverse weather conditions that northern and eastern have experienced, such as floods and drought, which directly affected their agricultural production. Both support vector machine and k-nearest neighbors are said to do better than the rest, as support vector machine has a very high generalization performance, while K and N has their special ability to assign each example to the majority class of its closest neighbors. Alright, so for the naive Bayes method, assumptions of conditional independence among some of the features such as land size can affect its performance, where it may not produce result with high prediction measures. Apart from that, decision tree results have shown that there was overfitting in that particular method due to noise in the data and generalization errors happen too, which are not good as observed. And this overfitting may lead to misclassification error where the class may be assigned wrongly and thus reduce the inconsistencies in prediction results. For all those four methods, integration of agricultural shock as a predictive variable is applicable in famine prediction, as it validates a strong contribution of environmental hazard in food production. According to Liu et al. And Ramo et al., they stated that a better understanding of data structure and relationship could be achieved by visualizing the data set in feature space. The study has also revealed that most households in Uganda are having food insecurity and live below the poverty line. Moreover, households in regions that receive higher and adequate rainfall because of the effects of convectional current from Lake Victoria are more food secure. So next, I'll pass it to Dr. Tasha.
Thank you, Dr. Hanis. So for the reflection of this study that has been done by Okuri and Obwa, it has several plus points in their strategy of assembling and presenting their findings. So we found that the study was in general very well encompassing and systematic. They had chosen learning models, which is SVM and KNN, that have previously been proven to be effective in the identification and classification of famine-prone subjects to be included in their studies. And they also predetermine which method was better in the generalization aspect. This helps to reduce the probability of misclassification error. So Okuri and Oba also used the domain knowledge gained throughout the study to identify several confounding variables or transform variables that were then excluded from the classification process to lessen the noise probability and the data variability. They also were good at identifying which region's dataset was the most reliable and consistent. So they applied that dataset into other regions that maybe had poor prediction performance. So additionally, this article presented the results in two parts, which are the visualization of classification and prediction evaluation. So the former, which is the visualization, allows the formation of interesting trends and patterns extracted from the results. So the reader and other researchers can see the results more clearly and help better understanding of the findings by these two researchers. So whereas the prediction evaluation allows the evaluation of the result produced by the four chosen methods through the assessment of the four measures, which are accuracy rate, error rate, sensitivity, and ROC. So these measures helps Okuri and Obwa to discern which aspect of the dataset
reduce or improve the performance of these four methods. So the percentage outputs for these measures are also tabulated. So that's another plus point for the ease of their analysis and for the ease of our understanding. So, for example, Okuri and Obwa deduced that assumptions of conditional independence among features such as lens size can reduce sensitivity in NB models, in naive Bayes models. So, in addition to this table, Okuri and Obwa were also able to distinguish which predicted feature had the bigger effect in which region. So, for example, the rainfall effect. The rainfall feature has a bigger effect in the western region due to its agricultural product needs. So the western region may planted an agricultural product that needs a rainfall. So it depends heavily on the rainfall. So as for improvement, next, under suggestions. Okay, so findings from this review suggest that the northern and eastern region had the best training data set for famine prediction in Uganda. So an improved data collection is needed for other regions in order to produce a consistent and reliable data set. So that because relying on other regions' data set might result in the regional inaccuracy of prediction. So next, the combined use of satellite imaging and updated socio-economic data is recommended for a better prediction. Another potential area of exploration is the transfer learning techniques. So, but first we have to determine if this contributes in any way for the refinement of classification accuracy. Lastly, information gathered from machine learning for famine prediction needs to be available in real time and not having to wait for biannual assessment as it has been done before. So recent events have made clear that this is possible to do. For example, the World Food Programme partnered with Alibaba Group to predict and track the magnitude and severity of hunger in over 90 countries approximately near real time. So it hasn't achieved real-time information update yet, but it's getting there because this article is from 2019. The system that they have created is called Hunger Map Live that enables digital visualization and analysis of the most up-to-date information. So another example would be the Famine Action Mechanism, FAM. This aims for a faster response in tackling and funding famine. So the World Bank has employed Microsoft, Google, and Amazon to work together uh, to uh, to form a real-time 6-month forecast of the potential crises and the funding that is needed for it. Next, for conclusion, I'll pass to Dr. Aina.
To conclude, machine learning techniques have proven to be well suited in predicting phenomena such as famine that have various causative factors. When applied, machine learning can perform structural data mining to accurately classify these factors. This is executed using various learning models such as SVM, KNN, NB, and DT, which algorithm can be trained with a data set that improve their prediction. However, for the same dataset, different methods may be performed differently. And these are the references. That's all from us.
Thank
Thank you.
you.
Thank you.
Thank you.